Box and whisker plots.
Looking at you makes me want to cry.
Why? Because
Okay. You have to put the numbers in order. Let's see, I'll just use these down here. There's 1, 2, 3 ones. 3 twos. 7 threes. 9 fours.
Wow, that's a lot.
No.
5 fives.
That's funny.
2 sixes. And a 7. Do I got them all crossed off, it looks like? Yep. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 30 numbers. So the middle would be 15. 15 on each side. If there's an odd amount, remember it'll land right on one number. You guys all understand that? Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 4 is the median. And then the first quartile would be the middle of the first half. And since there's 15, that means there'd be 7 on each side and the 1 in the middle. So that would be the middle. 7 on each side. That would be the middle. So then once you have that, you plot the lower extreme. I think I forgot to tell you that yesterday. The smallest number is called the lower extreme. The biggest number is the upper extreme. First quartile, second quartile, and third quartile. So if we made this, I think they made it for us. Yeah, it's right here. Just make a number line. It only goes from 1 to 7. You wouldn't have to keep going there. Now, one thing that they haven't talked about, but you did this in 7th grade, I don't know why they don't put this in here, is the IQR, which is called the interquartile range. You do need to know this for when you take MCA tests in a couple years, or ACT tests. Everyone know what the range is? Again, we haven't gone over that yet, but you did a ton of that in elementary. Anyone remember?
It's like the most.
Yeah. 7 minus 1, the range is 6. So if they ask for the IQR, any guess on what that would be? No?
What was the question?
What would the interquartile range be?
That middle.
So what would it be?
Lower.
No?
2. 3.
How do you get 2?
5 minus 3.
It's 2. It's the distance from here to here. The distance of the box is the interquartile range. So you just subtract these two. Okay? It's easy if you know it. It's not if you don't. Okay, so today we're doing stuff. I think you do got to make one box and whisker plot, but then some of it is interpreting. Now, here they have 2 pieces of information. They have mid-sized cars and standard 2-wheel drive pickup, comparing gas mileages, city driving gas mileages. Now, most of the time, you only have to do one number line. You don't have to do 2 number lines. You could either put them both below, or you could put one above and one below. Like here, this one's at 10. And then it's at 15, 16, 17, and then up to 24. So normally they just put them both on the same number line. Okay? So if you're comparing this, the lower extremes are the same. This one has a higher upper extreme. And if you look at the middle 50%, are right here. The biggest thing here is, remember, it goes in fourths. 3/4 of the mid-size cars are less than 17, because remember, this is a fourth, this is a fourth, this is a fourth. So you could either say 3/4 or what percent? 75% are less than 17. And then here, what would you say for that? From here to here, it's a fourth, and a fourth. So what's that? Same thing, 3/4 or 75% are more than 18. So if you're comparing these two, 3/4 of the cars are less than 3/4, or this is the pickups. 3/4 of the pickups are less than 3/4 of the cars. Does that make sense? Even though the bars are roughly the same length, most of the pickups are less than most of the cars. Because remember, this part right here is still just 1/4 of the cars. Okay? So, when you're answering questions about it, that's one of them, comparing the two. You look at the comparison like that. What is the median of the city driving gas mileage of the mid-size cars? What's the median of the mid-size cars? 20, middle number. And the median of the pickup trucks? 16. Which vehicle has the overall better city driving gas mileage? So which one has the best?
Car.
The car goes up to 26, so that would have the best. How else do the data sets differ? Right there. That would be the best thing. 3/4 of the cars are better than 3/4 of the trucks. Okay? So, that's really all it is we're doing today. Again, there's only a few problems we're doing on the box and whisker plots.